Hi guys, so what I'm going to do today is just go through some of the solutions to the problems that you have on that presentation. Some of these you would have done last lesson, but I'll go through the answers to them anyway, just in case you didn't get to them. So the first ones I'm going to look at here are evaluating all of these different problems. Okay, so what we're doing when we're evaluating, we're basically trying to simplify them or come up with the same number written in a more simple way, and usually that means a smaller way. So if we look at the first one, which is 36 to the power of a minus a half, the first thing we do is we need to deal with the minus, negative sign on the power. So we know that anything to a negative power is equal to 1 over 36 to the power and a half. Okay, so we've dealt with that negative power now. We've got rid of that. We also know that anything raised to the power of a half is going to be the square root of that number. So we can then simplify that to 1 over the square root of 36. Now, 36 is a perfect square, so we can simplify that further to 1 over 6. And that's our answer. Okay, so that's a lot simpler than what we had to start with. So let's look at G here. So G is 27 to the power of 1/3. Now anything to the power of 1/3 is a cubed root. So that is going to be equal to the cubed root of 27. Now remembering that the cubed root means that to get that number, you have to multiply the same number by itself 3 times. Okay, the square root is where you multiply the number by itself twice. Cubed root is 3 times. So when we're looking at a problem like this, we need to think, what number can you multiply by itself 3 times to get 27? Okay, and 27 does have a perfect cube root. Okay, so the cubed root of 27 is going to equal 3, because 3 times 3 times 3 is 27. Okay, let's go down to these ones. All right. So these are both cubed root as well. J is a negative cubed root. So once again, the first thing we do is deal with the negative first. So it's going to equal 1 over 100 to the power of a third. Okay. Oh, I think I've got the wrong number here. I think this is supposed to be 1,000. Because 100 doesn't have a perfect cubed root. Okay, so what this is now equal to is 1 over the cubed root of 1,000. Now the cubed root of 1,000 is 10, because 10 times 10 times 10 is equal to 1,000. So the answer that we're looking for is 1 over 10, or 1/10. Okay, so the last one we'll look at today is K, which is 125 to the power of a third. So once again, we can rewrite that as the cubed root of 125. So what number do we multiply it by itself 3 times to get 125? And the answer is 5. Because 5 times 5 times 5 is 125. Okay, so let's go on to the next slide. So these problems you'll find on the next slide of your presentation. And what it's asking you to do in this slide is write the following in index form. Okay, so what we're doing is we're essentially going opposite way. In the previous questions, we were going from index form back to our square root or surd form. Now we're going the other way. So if we've got the square root of 11, all we're looking for in this is to simply write it as 11 to the power of a half. We've now written it in index form. So remember, when we're asking to write anything in index form, it means that it has to have that index or that power there, which is this. Okay, part of the number, that's what we need. Okay, so let's go on to look at B. So going backwards from this is going to be 1 over 11 to the power of a half. Okay. Now, we know that 1 over any number is the same as that number to the negative power. So that is then going to be equal to 11 to the minus 1/2. Okay, so we're just working backwards in the opposite direction as what we were previously. So E, we've got a cubed root there. So this is going to be equal to 26 to the power of 1/3, because our cubed root is to the power of 1 over 3. Okay, and F is similar to what we saw in B, where we're going to have, that's going to be equal to 1 over 26 to the power of 1/3, which is then equal to 1 over, that is going to be equal to 26 to the minus 1/3. Okay, and I don't think we've got any more on that slide. So go to the next one here. Now, this is another question where it's asking you to evaluate without a calculator. So this time we don't just have straight square roots or cubed roots. We have fractions that have 2 numbers on the top. Okay? So let's look at how to evaluate these. So what we're going to do here to evaluate these is we're going to try and put the base number in an index form as well. So for our first question here, what we've got is 8 to the power of 2/3. So what we know is that we can also rewrite 8 as 2 to the power of 3, okay? Because 2 times 2 times 2 equals 8. So if we write 8 as 2 to the power of 3, we've got this. Then using our index laws, we can expand those brackets. So what happens then is we get that equals 2. Now we've got brackets here, so we're going to multiply the indices, okay? So we've got 3 times 2/3, okay? Which is then going to equal 2 to the power of 6 over 3. Now 6 over 3 we can make into whole numbers, okay? Because 6 divided by 3 is 6/3 is going to be 2 wholes. So that's also going to equal 2 to the power of 2, which is going to be equal to 4. Okay, so let's look at the next one. So 4. When we think about 4, how can we write 4 in index notation? And we can write 4 as 2 to the power of 2, because 4 is equal to 2 squared. Okay, we've still got our 5 over 2 outside the brackets, and now we can expand our brackets. So that's going to equal 2 to the power of 2 times 5 over 2, which is going to be equal to 2 to the power of 10 over 2, which equals 2 to the power of 10 over 2 is equal to 2 to the power of 5. So then when we've got 2 to the power of 5, that is equal to 32, okay? Because 2 times 2 times 2 times 2 times 2, 5 times, is equal to 32. All right, so let's look at G. Now we've got 9 to the power of negative 3 over 2. So what we're going to do first, again, is write 9 as in index form, okay? So that's going to equal, so what 2 numbers do we multiply together? 9 we can rewrite as 3 squared, okay? To the minus 3 over 2. So same thing here, what we're going to do first is we're going to expand our brackets here. So that is going to equal 3 to the power of 2 times negative 3 on 2, which equals 3 to the power of negative 6 on 2. Okay, now negative 6 on 2, we can divide those numbers evenly again. So 3 to the power of negative 6 on 2 is equal to 3 to the power of negative 3. Okay, And now we can use our index laws to simplify that further. So that's going to be 1 over 3 to the power of 3, which equals 1 over 9. So anytime we're evaluating something like this, what we're going to try and end up with is a number that doesn't have any indices anymore. Okay, so we're going to end up with a fraction, either a fraction or a whole number at the end. So a fraction or a number that's got integers. So let's look at this last one here. Same process. So 8, how do we write that in index? Seen previously, 8 can be written as 2 to the power of 3. Okay, we've got our minus 2 over 3 outside the brackets. We're going to expand our brackets, okay, which equals 2 power of 3 multiplied by minus 2 on 3, which equals 2 to the power of minus 6 on 3, which is equal to 2 to the power of negative 2, which equals 1 over 2 squared, which equals 1 over 4. Okay, so, oops, let's go to the next lot of problems. And we have here, write the following as a power of 2. So what this question's asking us to do is that it wants us here to have the base number as 2. So what we're going to end up with at the end is something in index form that has a base number of 2. Okay, so let's look at B here. So before we deal with the cubed root at the front, what we're going to do is how can we rewrite 32 as a power of 2? Okay, and the answer to that is, we actually saw this previously, 32 is equal to 2 to the power of 5. Okay, so now the next thing that we do here is we deal with the cubed root. Okay, so anything cubed root is going to be to the power of 1/3. So what we're going to have here is our 2 to the power of 5 to the power of 1/3. Now we expand the brackets like we did in the previous questions, which equals 2 to the power of 5 times 1/3, which equals 2 to the power of 5 on 3. And that is our answer. So let's go to the next one. So firstly, how do we write 4 as a power of 2? So that one's easy, 2 to the power of 2. We can then deal with 4 outside the square root sign there. So we've got 2 to the power of 2 to the power of 1/4. Okay, we're expanding our brackets again. So 2 to the power of 2 times 1/4, which equals 2 to the power of 2/4. Okay, and you can simplify that to 2 to the power of 1/2. All right, so let's go to the next one. We have, so here we have 8 underneath our square root sign. So once again, we're going to try and write 8 as a power of 2. So what's that's going to equal is 1 over this 2 to the power of 3 is our 8. Okay, so now what we do is we get rid of square root sign. So we're going to have 2 to the power of 3 to the power of 1 over 7 this time. We expand the brackets, and what we're going to get is 1 over 2 to the power of 3/7. Now what we want to do is we want to get rid of the 1 over 2. So this is where our negative indices come into play, and that is going to be equal to 2 to the negative 3/7. All right, so let's look at H here. H is tricky because we have to think about 64 and how we can write that as with a base of 2. So we've got this, and we can rewrite 64 as 2 to the power of 6. Okay, so that's then going to equal 1 over 2 to the power of 6 to the power of 1/5. That's then going to be equal to 1 over 2 to the power of 6 on 5, which equals 2 to the negative 6 on 5. All right, so I've got one more here that I've gone through with you. All right, so this time we've got the third, and then we've got the number out the front as well. So we want to be able to try and combine these two. Okay, so let's first write our 8 with a base number of 2, and we know we've done it a few times now that 8 is going to be equal to 2 to the power of 3. Now the square root of 2 we know is equal to 2 to the power of a half. So if we convert both of these numbers into index form with a base number of 2, we can now use our other index laws to simplify this even further. So we know that when we're multiplying two numbers with the same base number, we add the indices. So then this is going to then be equal to 2 to the power of, so that's 3 plus a half. All right, so how many halves in 3? So there's 6 halves in 3, so that's going to be 7 over 2. Okay, so that's when you've got to remember that realistically, if you're adding these two together, so remember when you're adding fractions, it has to have the same denominator. So if I show that in another step, you'd have 2 to the power of 6 on 2 times 2 to the power of a half. Now we can add the fractions together, which is where we get our 2 to the 7 on 2. All right, so let's look at these examples, which are from the last slide. So these are writing with a prime number base. So it's a similar sort of thing to what we were doing in the last slide, except now instead of using 2 as the base number, we want to have a prime number as the base. Remember, a prime number is any number that you can only divide by 1 and itself. So generally these are going to be our odd numbers. 2 is also a prime number. Okay. So, all right, let's look at the first one. So the first one, how can we rewrite 25 with a prime number base? And hopefully the first thing that pops to your mind is that 5 times 5 is 25. So we can rewrite 25 as 5 to the power of 2. 5 is a prime number, so that's okay to have as the base. That's what we want. All right, so now what we're going to do is we're going to get rid of the third part of this so that we've just got it in index form. So that's going to be equal to 5 to the power of 2 to the power of a third. Okay, we multiply those fractions again, and that is going to be 5 to the power of 2 on 3. Okay, so C, similar sort of thing. How can we write 125, with a prime base number? So what we've seen with 25 is that 25 is actually 5 to the power of 3. So we can rewrite it like this, which is going to be equal to 5, whoops, I should have the power of 3 inside the brackets, sorry. There we go. So 5 to the power of 3, and then to the power of 1 on 5 to get rid of that, so it's in index form. And then expanding our brackets, we're going to have 5 to the power of 3 on 5 as our answer there. All right, let's look at the next ones. So these are all a similar sort of process. So what we've got here is 1 over cubed root of 49. What two numbers can you multiply together to get 49? 7. All right, 7 squared is 49. All right, so we can rewrite it as this. Is 7 a prime number? Yes, it is. All right, so let's look at the next step for this one. Now we want to get rid of the surd. So we're going to have 1 over 7 squared to the power of 1/3, which is going to be equal to 1 over 7 to the power of 2/3. Okay, so we're getting rid of our brackets and expanding there. Now what we're going to do is get rid of the 1 or the fractional number there. So that's going to be equal to 7 to the power of negative 213. Okay, all right, so let's look at G. And this one's going to be a little bit tricky. So we've got to find a way that we can convert 625 with a prime number base into index form. So what we're going to have is 1 over... Now 625 is actually 5 to the power of 4. Okay. Now we're going to get rid of the surd portion. So that's going to be equal to 1 over 5 to the power of 4 to the power of 1 on 7, which is going to be equal to 1 over 5 to the power of 4 on 7, okay, which is then going to turn into a negative index number, like this. All right, so let's look at our last two. We've got I and K. All right, so this one, once again, is similar to what we looked at before, where we have got two parts to the problem now. We need to get 16 and 8 into index form with a prime number base, and preferably the same prime number base. Hopefully what you guys will both recognise is that both of these numbers you can have convert into index form with 2 as the prime number base. So 16 is going to be 2 to the power of 4, and then you're multiplying it by square root of 2 to the power of 3, which is 8. Okay, so that's going to be equal to, we'll say 2 to the power of 4 times 2 to the power of 3, power of a half. So that's getting rid of our square root sign. Okay, which is going to equal 2 to the power of 4 multiplied by, if we expand these brackets now, we're going to have 2 to the power of 3 on 2. Okay, so now remembering to be able to add our fractions together, we need to convert 4 to a fraction over 2. So that is equal to 2 to the power of 8 over 2. That's right. 8 over 2 is 4 times 2 to the power of 3 on 2. We can then add the fractions, which is going to give us 2 to the power of 11 over 2. All right, so K is also going to be tricky. And this one you may have to use your calculator to work out what numbers you need to use. All right, so what we've got here is we need to convert both of these numbers to a prime number base, and preferably the same prime number base. So what you guys might find is that 13 times 13 is actually 169. So we can rewrite this as 13 to the power of 1 divided by the cubed root of 13 squared. Okay, now we're going to expand our brackets. So we've got 13 to the power of 1, and then, so we're not going to expand our brackets yet. We're going to have 13 squared to the power of 1/3, because we're getting rid of that cubed root sign first. Now we can expand our brackets. So that's going to equal 13 over 1 divided by 13 to the power of 2/3. Okay, so now what we're going to do is, we know that when we've got two numbers divided by each other with the same base, I'll give myself some more room here, that we take away the index numbers. So this is where we have to convert 1 into thirds again. So what that's going to equal is 13 to the power of 3/3, because that's the same as writing 13 to the power of 1. Okay, divided by 13 to the power of 2/3. And then what we get is, that is going to equal, so now we can use our index laws. 13 to the power of 3/3, take 2/3, which equals 13 to the power of 1/3. Okay, and that's that done. Hopefully that helps you guys understand what's going on and be able to work out most of the answers to those other solutions there. Even if you work as a class, that would be great. Thank you.